Assalamualaikum, Jajahau, and Vanakkam. We are from Group Watehmelon and we are going to present the contribution of Discrete Mathematics, which is Dijkstra algorithm. Algorithm of a graph that ameliorate humans' life. Hi, my name is Shafi Masri.
My name is Niyata Murhana.
My name is Donovan.
My name is Anis Aziati.
My name is Nurul Izzati.
And my name is Nurdaifina Zafira.
The agenda for our presentation is to discuss these topics that is covered in our presentation, which are graph theory, the history of Dijkstra algorithm, its application to today's life, and the biggest impact of Dijkstra algorithm. At the end of this presentation, we will conclude everything. Next, we move on to the first topic, which is the graph theory. So why graph theory? Because if a Dijkstra algorithm, we need to know the fundamental of the graph, which is coming from the graph theory. So, okay. In the screen, you can see two graphs here, which is undirected graph and the directed graph. Because you can see that directed graph, you have the arrow at the end of the edges. So what is edges? Edges is a line that connected between two nodes or vertex. And what is nodes or vertex? Nodes or vertex are A, B, C, D, and E, as you can see here on both graphs. And the edges I denoted with E1, E2, E3, E4, E5, and E6, and E7. So what is this numerical label here? Which is 3, 4, 3, 1, 7, 2, 6. Okay, this is called weightage, or simply said cost. The cost between these two nodes. So like A to B, it costs 3, B to C, it costs 4, and so on. So this is the thing that you need to know to apply Dijkstra algorithm. So what is Dijkstra algorithm? Okay. Dijkstra algorithm is to find the shortest path between an origin point and the destination. Let's say we want to go from A to C. Okay, let's see the directed graph, okay? Let's say we want to go from A to C. So what is the best routes, we say, the best routes? The minimum cost that it takes from A to C. Let's say we want to take A, D, and then we go to C. So 6 plus 3, we have 9. So the cost from A, D to C is 9. But what if we take from A, B to C, it only costs 7, okay, instead of going A, D to C. So this is the shortest path from A to C. That is Dijkstra algorithm.
Moving on to the history of Dijkstra's algorithm. Here we have a picture of Edgar Dijkstra, the founder of Dijkstra's algorithm. He founded this algorithm in the year 1956. He was a Dutch computer scientist, a programmer, a software engineer, and a pioneer in computing science. He was also a theoretical physicist by training. He worked as a programmer at the Mathematisch Centrum in Amsterdam from 1962. Dijkstra was pretty much a lecturer his whole entire life, and at the Eindhoven University of Technology from the year 1962 to 1984. And he continued his career in the University of Texas, Austin from the year 1984 until his retirement in 1999. On one morning, Edgar Dijkstra was shopping with his fiancée in Amsterdam. They sat down to rest at the cafe terrace to drink coffee after a long walk. He then questioned himself about what the shortest path to travel from Rotterdam to Groningen is.
He then came up with the whole algorithm to find the shortest path within 20 minutes by using a weightage graph. However, he said that although the algorithm can be applied on either directed or undirected graph, his algorithm cannot be applied when the weightage is negative value. His 20 minutes invention was soon published in 1959, 3 years later. He also added that the publication was a marvel as he designed it without pencil and paper. Eventually, the algorithm became his great amazement and one of his cornerstones of his fame.
Next is application of Dijkstra algorithm for today's life. First is digital mapping in Google surveys. Using the Dijkstra algorithm, the shortest path between the sources and the destination can be computed. By iteration expanding the sets of vertices as to the shortest path, then it will determine all the shortest route from the sources vertex to each vertex. A prioritized queue determines the next vertex and adds to S at each stage of the algorithm. It will loop back over the priority queue, processing the next vertex at the top. When the priority queue is empty, the algorithm is complete.
So the next application is the airline flight software. So this software is used by travel agency. You can see here the graph. We have nodes A, B, C, D, and E. What is these nodes represent? So these vertices represent the airport, which means airport A, B, C, D, and E. Next, this airport is connected by a directed edges, which represents the cost. This is the formula, which is arrival time minus the departure time. We have T here, depart at means the departure time. So let's say from A, so departure time is at 1. Okay, if it goes to C, so it arrives at 7, so A7. So this is the arrival time. The cost taken from A to C is 6. So the origin airport is at A and the last destination is at E. So our target is E lah. Now we need to know the earliest time from A to E. So let's say we want to take A to C and then C to D. So let's see. So A to C, it departs at the time 1 and it arrives at 7. And then it wants to go to D. It is impossible because if it arrives at 7, the flight is take off at 5. So it is not possible lah. So we cannot go from A to C to D. So we need to go from A to C to B. So what is the cost taken? 6 plus 1 is 7. So it's 7. But the target here is B, right? So why not we just take A to B? She's only cost 4. So that is Dijkstra algorithm. It will find the minimum cost taken from a vertex to another vertex. So A to B, which is cost 4. And let's see, B can go directly to E, but it costs 6. So what if we go from B to D to E? So it will cost 4 plus 1, 5. 5 plus 1, 6. Okay, what if we take A, B, and directly go to E? So 4 plus 6 is 10. So that is higher than the cost taken from A, B, C, and E. So the shortest path taken for this airline is A, B, D, and E. So that is Dijkstra algorithm for airline flight software.
Next is telephone network. We can discover the shortest path from the sources to all other nodes in the graph that represent the networks, while calculating the distance of nodes and the destination nodes. The vertices is the switching station, and then the edges is the transmission lines, and the weight of the edge present by B if we envision the city as the network. So by that we can find the shortest path using the Dijkstra algorithm.
The third application is the IP routing in finding the open shortest path first, or simply said OSPF. So OSPF is also known as Dijkstra algorithm if you try to find it on Google. So what is the OSPF aim? So the aim is to find the shortest path from destination source by the router or to reach accessible subnet or network. In figure 2, we can see there's a gray rectangle. This is the subnet. Okay, this is the subnet, and the buildings here represent the LAN, LAN, LAN. Okay, and the subnet, when the subnet is connected like this, the line is called the routers. And then the routers, subnets, and links are converted to tree. So in figure 3, you can see it is converted to tree, which take R2 as the root. Okay, so what is OSPF find? What is OSPF aim again? It is to find the minimum cost, which is, you can see here, the green line and the red line. So if you sum up all together, which is we go for the green line first. 1 plus 10 plus 1 is 12. So this is 12, cost 12. And 1 plus 10 plus 10 plus 10 and plus 1 again, which is cost 32. Okay. So from R2 to R2 here, it costs 32. From R2 to R5, it costs 12. When we arrange the tree that we just converted just now to its original network, it will look like this. And we can observe the shortest path taken. So that is how we apply Dijkstra algorithm in IP routing to find the shortest path first.
So moving on to the biggest impacts of the Dijkstra algorithm to humans' life. So the impacts is the creation of the online map apps application, just like Waze, Google Maps, and for the delivery man, for Grab, Foodpanda, and other sort of app. By creating these apps, it will save people time to start their travel from a certain place to their destination. With this, they can save their money for the cost of petrol and the Grab fee and for the taxi fee also. By saving this time, it will help saving people's life. As for the ambulance or firefighter emergency unit to find the shortest path to the nearest place to save them. So moving on to the other biggest impacts, which is reducing the challenges in transmitting process for the telephone network from one place to another place. From the application part that we seen about airline flight software, it gives software developer a job opportunity to create an application which is suitable for travel agency to use.
Next, to conclude, the Dijkstra algorithm has a lot of advantages that can benefit us in real life. It has almost linear complexity and can find shortest path to a destination. However, the obstacle while implementing the algorithm on the internet is we need to provide a full representation of the graph to execute the algorithm. All in all, we can learn a lot of things in discrete mathematics that can be applied into our daily life. With the existence of the Dijkstra algorithm, humans can find the shortest path to the destination that could save their time.
That is all from us. Thank you.